I give you Lefty Gardner and Wide Lightnin.
How awesome is that? That's what this project's about. This is the 5th scale P-38 Lightning. It's going to be the white lightning. This we're actually making at the moment and about to make a mould of. And this video is about the compound panels and how we go about making the panels. All the flat ones, it'll just cut from a straight piece of, a flat piece of plastic will just go on. But there are so many of these really curvy, compound curvy, we call them specials. And this is about how the process that we go about making them. The basic concept is to extract the panel that we want to make from the 3D drawing and then create a 3D toolpath which gets cut on the CNC router backwards into a block of hard foam, and then that gets filled with plaster. So this is the foam that we use. It's just a hard foam from Bunnings. So we pour the plaster, we end up with a plaster shape, and then we vac form over the top of this, and that forms the actual panel. Once the panel has been pulled, it gets trimmed to fit properly onto the plug into position, and the rivets have to be put on by hand using the machine, and then that gets stuck on straight onto the plug. The video is going to be a bit technical, and it may not be terribly riveting to a lot of you. We're going to be going through the process of using Rhino 3D, that's the CAD program that we use, and in particular MadCam, which is a Rhino plugin that creates 3D toolpaths. So taking the extracted panel and showing how we create a toolpath for the CNC router to cut the foam. And we've got a friend who's making a Grumman duck in a similar way, and he'll be needing to put lots of compound curved panels onto his plug. So this is particularly to show him the process.
So what we're doing is that panel. So from the 3D model, so there's the 3D model, and there's the panel there. So we've actually pulled it out here. So you can see how that panel's still the shape of that. We've added 20 mil to these sides already, just extended them out, so we've got a bit of pull area. So when we pull it, we've got trim area on the mould.
Pull it as in vac pull it.
Vac pull it. So we're going to make a panel, a compound curved panel. So to do that, we're going to make this tool path to cut it backwards into foam to pour plaster into it. So that's what we're making. So to make it backwards, we've obviously got to tip it upside down, because that's the shape that we're going to be wanting. Does that make sense?
Yeah, that's the shape you're going to cut into the foam.
So from this direction, we want to square it up so it's not sort of wasting foam. We want to get it sort of square with a block of foam, so something like that. And from right view, yeah, that's not a bad shape. So we've got that shape, but upside down. We want to fill the corners in. So we want to put a nice little curve around the corners, and maybe a big curve around this corner.
So you want to fill the corners so that you're making a box that you pour plaster into.
We're going to machine a flat surface into the foam, so it's got to be a nice shaped bit, so it's not sort of lumpy bumpy. So we'll duplicate an edge. We'll duplicate these edges. There's a little ugly bit there. right on there. So we've duplicated those edges, join them up, and then we can use arc blend. So from there, curve, we'll go up and just select curves in the filter. So curve, curve, puts a nice little curve in there, joins them up. So we go around all the corners and do that. Hit enter, reselect. This one's going to be a big curve. So we're going to go from there to there. Hopefully not too high. That's probably a bit high.
Can you just turn on the points and push it down?
Well, so many points it's put in there. No, we'll just trim it off afterwards, I think. So then we want to fill those in with surfaces. So surface, curve network, and you select the, turn surfaces back on, that one, that one, that one, and it puts a surface in there. So again, make a surface between that edge, and that curve. Done.
So points define curves and curves define surfaces.
So we're defining this surface with a series of
Curves.
3 curves. And this one is going to be a little bit messier. So there's a surface, but we'll trim that down. So that's sort of the roller coaster ride that we want to cut into foam. Just to get an idea where its size is at, we will analyze bounding box, outputs, curves, and draw a box around it. You can see, so if we go to front view, that's way too big. The bit we're actually after is this black bit. That's just a lead out. So if we chop that blue bit to the level somewhere through there, so we want to chop that, so we go up and draw a cut plane. If we just through there, that'd be maybe just a fraction higher. And then, so using that as a cutting plane, so that's drawn a cutting plane through that wing, and trim off that surface, and that curve will get rid of that, and get rid of that cutting plane, get rid of those daggy little bits. So that's the shape that we want to cut into foam. So that's what we want to cut, so we select it, and then we start into MadCam. So MadCam, you work down the...
And MadCam is?
Machining.
Machine and die.
Machine
but
and...
it's what's making the 3D toolpath.
Yeah, it's an add-on to Rhino. It's a plug-in for Rhino, which creates 3D toolpaths within Rhino.
And works within Rhino itself.
So it's here as another menu. It's like it's a separate menu in Rhino. There's 3, 4, 5 axis toolpaths. We're just using 3. So we've selected what we want to actually cut, which is this shape. So start at the top, select the model, and that's now drawn a box around it. For Rhino, for simplicity, our cut is going to go from world 0, 0, 0. So we can select this whole thing, go move, again, accuracy, snapping everything. So point to move from will be that point there, and we are going to 0. So on the construction plane, that is now set at exactly 0, 0, 0. So when we go to cut it, that's the starting point for our cutter bit. Will be at 0, 0, 0. So it'll go X positive, Y positive, and Z negative. It's going to cut down into the block. So that's the surface of the block, and it's going to be cut down into the block. So now that we've moved that, we've now got to do that again. So say that's the model, that's what we're cutting. Working logically down through the menu items, we select the cutter bit. We're going to cut this with a ball end 12mm. That's just a tooling choice, works good on foam. So we select our 12mm, it's going to go at 1200, 600 feet, 12mm diameter. Okay. We now have to give it a region curve, so it's not cutting outside what we want. We just want it to cut exactly what we've got. So we'll select another layer for convenience, and what we do is just zip around the outside, marking the silhouette of it. So we're just duplicating edges. Yep, duplicate edge, join them. It's an open curve, we'll get back to that. So, I didn't select that. Yes, I did. We want to bring all that now up to the top to form our region curve. So that's a transform set point, set coordinates in the Z level. So we're going to bring all that up to the top. You can see what that's done. It's taken that outline and built it, compressed it in Z to the top. This may be an issue, getting a 12mm bit down there. We'll see where the toolpath goes. Not a big issue because we're not really interested in that bit, but we'll see what it does.
And you had to close it.
We've got to close it. So the region curve must be a closed curve. So that curve there, to make sure it's closed, we go to curve, curve edit tools, close curve. And it's closed one curve by adding a line segment. So that's now a closed curve. So we go across back to MadCam and go to select region curve. So this curve is highlighted. Select region curve, and that's now the region curve. So it'll only create toolpaths within that curve. So then we're not profiling and pocketing, we're doing a surface milling. So we bring that out, we can actually detach that. So we can keep it there. So there are 3 steps that we're going to use there. There's roughing, Z levels, and planar. So if we click roughing, we're using a 12mm bit. So we're going to not step down dramatically, but we're going to hack away a bit. So 10mm step down, it's a 12mm bit, so a 6mm step over. And we're going to leave a little bit so it doesn't go right up to the edge from the roughing, 2mm. So stock to leaves 2mm. And go. And that creates a toolpath. It'll create a toolpath under MadCam in the layers. So it's working out the toolpath. And there is the roughing toolpath. So you can see how it's stepping down 10mm at a time, not going right up to the edges. So that's the roughing toolpath. So that'll take away the bulk. So if this green represents the hunk of foam, it's chopping away this bit, which is roughing out the shape. Next step, I'll turn that, you can just hide that for the moment, the roughing toolpath. The Z level, which will do basically vertical surfaces. 1mm step over, step down, that's reasonably fine. So this is a finishing cut of the vertical-ish surfaces. Stock to leave 0, so we want to go right to the edges. Step down 1 and we go yes. So I'll create another toolpath now, which is the vertical, which aren't that many vertical surfaces. And that's the Z level. So every level, starting at the top, 0, it goes down 1mm at a time, and comes up with a toolpath which joins all those levels together in a nice tight pattern. So it's stuck it over here, Z level. We can turn that off and then do the planar finishing, which is the horizontal surfaces. So again, 1 mil step over, 0 to leave, so it's going to machine the finished surface, go. Calculates the surface of the toolpath, and there's the planar finish. So when you turn that back on with the Z level, it's covered that whole surface just within the region curve. Couple that with the roughing toolpath, and that's the complete toolpath to cut that shape. So the blue, the light blue, is the actual cutting. The dark blue are the rapids, fast movements between cuts. So now that we've created that toolpath, we post-process it. We turn that pretty drawing into a G-code, which Mark III can then get the machine to cut it out. So this is the post-processor. So making sure that these layers are all visible, because it'll create a toolpath for the visible layers. You can, if they're all on, it'll create a toolpath for it. So post-process it. It's a 3-axis machine we're cutting on, and we're using Mark III metric. And you go post-process. We're going to give it a name, which is the left boom, front, top, outside panel. And save, and there's the details of the G-code for it. It's going to take 54 minutes to cut. And if you, job done. No, done. Close. Take that G-code over to Mark III and start a cutting.
We now have the panel shape cut reversed into foam, so now time to fill this with plaster. So by adding some soapy water, just a squirt of dishwashing detergent into a glass of water, this gets rid of the air bubbles on the surface, the plaster piece, by breaking up the surface tension in the foam mould. And not just the mist of soapy water, but really soak it and give it a good rub into the foam surface. That'll make it come out really smooth instead of all full of pox marks and holes, which take a lot of filling and smoothing. And then just a quick sand with 400 wet and dry, used wet, and it's smooth enough to back form over. Mix your plaster, pour it into your cavity and give it a bang to help get rid of trapped air bubbles and to settle and level it. We use an oven element to heat the plastic, but just use the heat gun to get right to the very edges and the corners on the bigger bits of plastic so that it heats really evenly. Remove the pull panel from the plaster plug, roughly trim it up and check it for fit.
Ta-da.
How good is that? That's going to fit into there really neatly. The panel then gets really finely trimmed for an exact fit into position, matching the surrounding panels, and then the rivet details embossed into it. We use the CNC router by manually positioning the panel under the rivet making tool and then using a handwritten single rivet depression making G-code. A rivet's embossed into the plastic. And then manually line up the next position and repeat, and so on. To keep the rivets on the line they're meant to be and evenly spaced, a vinyl sticker is cut to the correct spacing and stuck on as a template. And then finally, the panel can be stuck into position on the plug. Clean up all the glue, finally sand and then polish with a polishing compound. And there you have it. One panel finally done and dusted. Just have to repeat that entire process from the start for every special panel. Yeah, I know it's been a really long video, and Per, we sure hope this helps get you started with MadCam. This video bizzo is a lot more time consuming and harder to get right than we thought it would be. But you know, it's pretty hard to describe this stuff without video and talking. So I hope you get something out of it, and thanks for watching.